Good morning, good afternoon, good evening, wherever you may be hailing from. My name is Eric Hendricks, and this is CIQ's first webinar of 2026, if you can believe that. I want to welcome you all today. Today, we're going to be talking about an exciting topic built around Fuzzball. We're going to be talking about sovereign AI and interactive HPC, unifying training, inference, and exploration in one workflow. So that is a lot of words. And I could tell you all about it, but it'd be far more interesting if I brought a few people in to tell you about it for me. We'll get a little bit of a conversation going on. But before I introduce my guest today, a little bit of housekeeping. We are live, if you haven't noticed, over on one side of your screen. It's either that side or that side. There is a chat box. Feel free to say hello. Let us know where you're watching from, and if you have any questions during the course of this event, feel free to put your questions in there. And I will make sure that one of our amazing guests will be available to answer those questions. We'll answer those live on air to the best of our ability. I think that's it. So if you haven't, make sure to visit our website, sign up for our newsletter. That way you get notified anytime that we do these events. We are planning on quite a few of them, covering Fuzzball, Ascender Pro, Rocky Linux, all the things that CIQ is passionate about. So really looking forward to this. And with that, I will shut up for a moment and introduce our guests. Dave, would you like to go first?
Yeah, sure. Thanks very much. So my name is Dave Godlove, and so I'll just tell you a little bit about myself. So my background is that I used to be a neuroscientist working at the National Institutes of Health, and I became interested in high performance computing while I was there. And so I joined the BioWolf team as a staff scientist, working at the intramural HPC resource at the NIH. That was about 10 years ago. It was around the time that containers really took off within HPC. And so I've been kind of an HPC container nerd ever since. And I work with the Fuzzball team primarily, and I am a technical product writer, but I also do a lot of HPC engineer, testing, all kinds of stuff.
Awesome. Well, glad to have you today. Jonathan.
Yeah, so my background is in HPC as well, but more on the systems side. So I don't have any research science or academic background there, but my job historically has been to support research and scientists using an HPC system, and I've done everything from the queuing system to the network to the storage to the Unix systems that undergird all of that, and joined CIQ 3.5, 4 years ago, something like that. Now it's getting a little bit. And now my role here at CIQ is as a product engineer. So I'm primarily responsible for our HPC products, which encompasses Fuzzball, but also Werewolf and Werewolf Pro, and to a slightly lesser extent, but still part of the conversation, Aptainer, largely as part of that Werewolf product stack. And yeah, really excited to talk today about new features that we've been able to add into Fuzzball that I think have been a long time coming. They're filling a pretty big need in the product.
Awesome. Well, thank you both for those introductions. And I realize I don't know that I introduced myself. This is my first appearance here on the CIQ channel. So real quickly, my name is Eric Hendricks, known online as the IT guy. And I've been a Linux systems administrator. And then around 2019, I dove into the dark side of sales and marketing, found my love of teaching and content creation. And so now I spend a lot of time talking to other sysadmins and nerds about what it means to work with Linux and containers and other similar technologies. So if you've seen my face, it's probably because you're used to seeing me at this angle or conferences. So really excited to be here. I've been part of the CIQ team for a whopping 3 weeks now, and they felt comfortable handing me a microphone and a webinar. So we'll see how this goes.
Welcome.
Yeah, great to see you, Eric.
Yeah, good to be here. Good to be here. So, Jonathan, I want to throw the first topic your way. So right now, folks that are getting used to this idea of hosting their own AI. So we're not talking about ChatGPTs here or Claudes here. We're talking about we need something a little bit more specialized. We need something maybe that's sovereign, something that we host in our own data center, with that's cloud or hybrid or local. But right now, there's kind of two aspects of this problem. There's the training aspect, training the model to know the things we needed to know, and the inference side. And right now, the industry sees those as two very, very separate tasks. So kind of talk us through what kind of let's flesh out that problem. Let's define what we're trying to solve here between sovereign AI training and inference.
Yeah. So a big part of CIQ's positioning for Fuzzball and frankly most of our products, maybe all of our products, is this idea of you, the customer, having complete control of your infrastructure and your data and everything that you're doing. And that's a little bit at odds with the way a fair bit of the industry is going right now of, hey, give us your data, give us your systems and run it on our things and trust us, it'll be okay. So there's a time and a place for that. And I'm using Claude all the time right now. But depending on what data you're wanting to process with an AI model, you might either be prevented from doing that regulatorily, or you might just not want to. You might have business secrets or whatever, the data that you don't want to leave your premises or your control. So our goal is to enable that full stack to run in your infrastructure with your systems. And your infrastructure may still be the cloud. It may be some contractual system that you run outside in AWS or something, but it may literally be equipment on your premises. So where this comes up in the AI conversation, you mentioned training. I want to break that down a little bit because that gets to be a little bit of a fuzzy term. There's training of the model itself that you do on large corpuses of data for weeks or months or longer. And that is certainly a thing that you can do as a traditional batch process and could conceivably do on Fuzzball. It's not necessarily what we're targeting with what we're going to show off today. It's certainly not the part that's enabled by the new functionality, service endpoints, that we're happy to show off. Fuzzball has been from the beginning a batch processing engine that can do large parallel work, and you could do that or you could use that capability to train a model, let's say, of various sizes. But there are other parts of what can be thought of, what people might think is training, that are not quite that same thing. You might fine tune a model. You might take an existing pre-trained model and then give it additional data about your specific data set, your specific concern, your specific industry, and retrain that model with more information to be specialized for your use case. That's one thing that you can do that you might want to do. The other is through various means bringing data into a vector database or a RAG database that will give that model access to information that it might want to look up during its execution. So when it's inferencing, when it's answering a question, let's say when you're asking it to produce output, a database like this gives it access to, well, maybe I can keyword search and get fuzzy information about Fuzzball. That what we tend to do is show off asking it questions about Fuzzball, and I'm sure that's the thing that we'll do here. Ask it questions about your product or your support database or whatever information you've brought in, and it can answer questions about it like you would if you were accessing that information. That's a computationally intensive process as well, because there is an inference step in looking at the data and deciding what keyword searches, let's say, for example. That's not quite how it works, but you can imagine it. What searches the model might produce into that database and what results it should get out. Building that index is computationally intensive as well. That's also a bit of a batch process. But then the final step is that inferencing step, which you can do as a batch if you have a whole bunch of prompts or you're going to generate a whole bunch of images or something like that. You could do that all as batch work as well. But more commonly, people want to do that as an interactive process. You might do that initial ingest, that initial retraining as a batch process, but they want it to terminate in a final model that's running as a service that you can ask questions of, you can log into, and just use in your day-to-day work. So that's the new capability that we've introduced into Fuzzball, that you can put both of these kinds of work together in one platform that a research scientist or an IT person like me, or really anyone, could run with the platform and use.
That's awesome. Yeah, and I forgot to mention that the reason why we're doing this topic today is we just announced service endpoints. So that's kind of a big deal. So appreciate the explanation, Jonathan. That really helps kind of clear things up a bit. Dave, I'm kind of curious with your hands-on practical background. is this something that you wish you would have had? What are your thoughts?
Yeah. So to get back on talking about service endpoints and that being kind of the impetus for this work. So um, it's kind of funny because a lot of times when we introduce Fuzzball, what we talk about is we say, well, it's container orchestration, right? And that's really what it is at its heart. And so then a lot of the next logical question is like, well, how is it different from Kubernetes? And the answer to that is, well, it's an entirely different mindset because Kubernetes mindset is focused really on services and taking multiple different microservices and sticking them together and allowing them to talk to each other and do things like that. Whereas Fuzzball is focused on jobs. And so with that explanation, then it becomes kind of surprising when you go back and say, and now we're doing services. But the reason for that is just what you said, so it is, we found both through experience and also through talking to other HPC engineers and so on that, users of HPC do need services, right? I mean, if you think about how many of them want to run Jupyter notebooks, for instance, or want virtual desktop environments, or you want to visualize something with ParaView or something like that. But these services, they're still a little bit different than the kinds of services that you would normally be thinking about when you were thinking about Kubernetes. They're not necessarily services that need to sit behind a big kind of networking stack with ingress and egress and all that kind of stuff that they don't need to necessarily have like load balancing and high availability. Basically, a user needs to spin up a lot of times a server and then connect to it or have a job connect to it and interact with it. And that's essentially what they need to do. And so that's kind of the way that we're thinking about services within Fuzzball is once again from an HPC user's perspective. And this, once we started thinking along these lines, it really, with the sovereign AI idea, it really kind of began to blow up and say, oh, well, wait a minute. There's all these things that we can do as just as Jonathon was saying, as far as like training and augmenting existing models and then serving them out all within the same workflow. So I think that's all those topics are really what we're going to be kind of covering and talking about today.
Love it. So Jonathon, back to you. So we kind of talked about what the problem is. So where does that bring in the solution? How do we fix this problem?
Yeah, so for Fuzzball, so I kind of skipped over. It's because we're talking about Fuzzball all the time. It's sometimes easy to forget to just introduce what is Fuzzball. Fuzzball is CIQ's vision of the future of high performance computing in a massively hybrid environment. So you might have some resources in the cloud, you might have some resources locally. You want a single interface that lets you operate all of your compute wherever it is, and you want your workflows to run the same no matter where they run. So there are a number of technologies that go into this. We have a workflow definition that talks about how one job flows into the next and how their inputs and outputs interact. We have all of our jobs are containerized so that they bring their dependencies with them. And so that if I run my job here on this environment, it has the same code and same libraries as if it runs in that environment over there. But what it's been historically is it's batch processing. And you can, we have a web interface. It's all nice and easy to use that can show you a block diagram of your environment, of your workflow. But it's been exactly that, a batch processing system where you have a batch job that runs in a batch job that goes to another batch job, and you can run multiple jobs in parallel, and then a final job might depend on multiple outputs from multiple previous jobs, and it can break it up and parallelize it that way. But for this final result where you want to monitor your job in real time, maybe visualize it with something like ParaView, or you want to run a desktop suite, you want a virtual desktop, or our kind of prime case here, you want an AI model that's going to run and be interactive over time. That is something that we've had to in the past kind of simulate, where you ran a normal job and then you had to port forward into it either using SSH or using the Fuzzball command line. And service endpoints alleviates that. Now, in addition to having batch jobs in your workflow, you can have a service in your workflow, and that service can have the same relationship to other jobs that the jobs themselves have with each other. It can depend on other jobs having completed or being running right now, and then you can log into that service using an endpoint. Technically, we can have multiple endpoints in a service, but I don't think we've done that. And so you can click a button in the web interface and get access to a virtual desktop that lets you interact with something that's running in parallel. Or you can push a different button and get access to a Jupyter notebook and do some data science there and manipulate a data set that you have in real time. Or you can press a button and access an AI system and an AI model that's running and ask it questions just like you would with Claude or ChatGPT or something like that.
And don't underestimate the ability to add a lot of this configuration into a tool like Ascender and using Ansible playbooks in the background. You can further automate a lot of this using Ascender Pro.
Yeah, so we tend to use Ascender as a deployment mechanism for Fuzzball, depending on the environment for sure. We don't have anything in the front yet that runs things in Fuzzball with Ascender. We should do that. That could be cool. Oh yeah, I'm just reading this post here from Gwen. Thanks, Gwen, for putting that up there.
Let's see. Okay, so we kind of talked about this problem between training and inference. We've kind of talked about what Fuzzball is and how Fuzzball can kind of help this solution. But some of our audience may be sitting out there wondering, is this a problem that I'm having? Is this something that I can really contribute to, or is this a solution that I can? Words are hard today. Is this a problem that I can? Is this a problem that I have? So let's talk about some specific use cases. When would sovereign AI and some of these tools like service endpoints really come into play?
Well, it might be easiest to make that case just by pulling it up and walking through some use cases and showing what that looks like. Are we ready to do that, or what do you think?
Dave, you have anything to contribite before? I forgot to
absolutely.
tell everybody we got shiny demos today.
Yeah, we do. Yeah, I surprisingly I do have something to contribute today. So yeah, no, I think that audience members might be having that kind of question. They could be thinking to themselves, is this a problem that I have that is going to be solved by Fuzzball that I can use? And I think that a lot of the times, and we know this, but it's good to be reminded. A lot of the times when you've got new technology that you have access to, it doesn't only solve problems maybe that you were thinking about, that you already were aware of. Sometimes it solves problems that you didn't even know that you had. And sometimes it doesn't really solve problems, but it opens up new avenues for research that you didn't realize, that are just like, oh, I never even thought about trying to do this. And now I can do this. I can incorporate visualization, for instance, into the middle of my my HPC workflow, and I can kind of pause it and go in and select some stuff and then resume it, based on, and I can, analyze data based on the regions I've selected in this particular model or something like that. So yeah, it really, I think once we start kind of showing it off here momentarily, I think it's really going to open a lot of eyes, and it's probably going to spark a lot of ideas.
I will say that the addition of this functionality has been the first time that I've been this excited, not only to be, we use the term dogfooding, using Fuzzball within the team, within CIQ itself, even though, we aren't HPC people, but suddenly it becomes useful for a much broader set of things that we keep making the case. Computing is high performance computing now. Right. Most of what we're using our computers for, certainly all this AI stuff, is performance sensitive. You need real horsepower behind it. So I've been excited to use it kind of as part of the development process. But I and other developers on the Fuzzball development team have all expressed like, oh, I could use this at home. I could be doing this cool internal sovereign AI stuff, just as a hobby thing too. And Fuzzball is enabling that. But, part of the point of it is that it's scalable to all of these use cases. We want it to scale down to local development and interesting small things, but then scale up to large production scale work also. And this is definitely a step towards that.
So what you're saying is I should use this technology to run my sovereign AI that serves as my co-DM for my Dungeons and Dragons group? Is that what you're saying?
You probably should, yeah.
You should. Totally should.
But I can also see like a future I mentioned I'm using Claude. We use Claude and other AI tools internally as part of development. But there's a future where maybe you don't want to have your code exposed to an external AI model. And what if you could run an open and community accessible model, or even a proprietary model that you buy, and then run internally on your local infrastructure and don't have to expose your code out to a third party? That's the future we're trying to enable here. It's of course computationally intensive, but even beyond just having the equipment for it, running the infrastructure can be its whole own thing, and we're hoping to make that easier.
Awesome. Well, I'm sold. You can take my money, or we can just jump into the demo. What do you think?
We can do both. I'll take your money and we can give a demo.
I got your screen up here, Jonathan.
Yeah.
What are we looking at?
Great. So I just realized my computer is not plugged in. That could become a problem later. So this here is the Fuzzball web interface, and we're right now looking at the workflow catalog. This is one of the things that we're really proud of with Fuzzball, that because the workflows are portable and run the same regardless of where they run, we can build a workflow for you, and you can run it in your environment, and it will work the way it worked when we developed it. And these are templated, so when you run one of them, you're asked a series of questions, if there are questions for it, on what inputs and outputs you want for it, maybe what storage you want to provide for it, depending on the workflow. Each can have its own inputs and outputs. But this alpha fold one, for example, I think, yeah, that's this one that I've got pulled up here. This is that block diagram that I mentioned, and we can zoom out. Oh, not even far enough. This one's really wide. But this is a series of batch jobs, right? And most of these are not dependent on each other, so they're running kind of whenever they can, whenever there are resources available. But then there's a final job that needs output from all of them that runs a final prediction, apparently. And then this is all batch work, and it concludes and your workflow is done and you get an output. But what if you wanted to be able to view the output of that, either when it's being generated, or kind of monitor the process of this? You can, of course, monitor the workflow itself through the Fuzzball interface, but you need some kind of bespoke interface. That's where the service endpoints come in. And so, like the most obvious example of this, something that you want to run and be interactive with as you go, is a virtual desktop service. The icon for this one is a little bit more generic right now because I've had to modify it to support service endpoints. We just got that working. But we have this workflow running, and I have some data in a volume that's persistent between runs. I can mount whatever data I want to it. It's running this container that we have that runs a virtual desktop, and using XFCE. It could be whatever you want, but this is a lightweight one. And because this is a service, you see it says persistent service. It's going to keep running even when there aren't other jobs in this workflow. Something we haven't actually done much of right now is an in workflow service. It's really only meant to be running when other jobs are running, because maybe the jobs need to use it. That's a thing you can do with this. That would be an ephemeral service. But this persistent service is something that will run forever until I stop it. Unless there's, you can have a time limit on it or something like that. But I've got an endpoint configured here called desktop that I can just press this button on with this running and connect to this VNC instance. And here it's running from before because I got it all set up ahead of time, but I have, some graphical stuff running, high frame rate in my GLX gears, of course. And I can browse the file system. I can see where that data was mounted. I think the data is just mounted to the home directory here, so that would be persistent. But then, you would use this, for example, if you're using a desktop suite, like the ANSYS suite of software has a workbench product that needs to be run in a desktop. And so you could use this to run that on a shared infrastructure. By shared, I mean like multi-user infrastructure that you control, but it doesn't have to be the desktop sitting in front of me. And then that can interact with other parts of the Fuzzball cluster as well. Another popular system for this is Jupyter. The Jupyter project grew out of the Python and IPython communities to do interactive notebook computation, where you could have some documentation in Markdown and interleave that with interleave that with code blocks that could execute and generate output in the notebook, and then you could package that up and save it. Running these, however, on an HPC environment is tends to be that thing I described earlier, where you run a job and then you SSH port forward to it and access the thing that's running, or you run it locally on your local workstation. But with service endpoints here, I have a persistent service for Jupyter, just like that virtual desktop. I can click this connect button down here, and all in my browser, I can access the notebook that I had before. I actually, it's actually kind of cool to just see how easy this is to do. So I'm going to delete this right here and just drag this notebook back in. Oh, if I can find it. Oh no, I think this is it. Yeah, right here. And just interact with it as though it were running in any other Jupyter environment, but have it be mounted to my external storage that is part of my infrastructure, and dispatch from here onto multiple nodes that might be running in the background as part of the same workflow, and then execute the command blocks here. So I can say restart kernel and run all cells, and we can see this Python code, over time executing the code that's in this notebook. It takes a little bit to initialize this first time where it's bringing in matplotlib. But yeah, here we go. And it'll generate some matplotlib graphs and things like that. So that's two of the really basic examples. The next one then is the AI workflow, which I would throw to Dave for, unless we have more to discuss before then.
Well, maybe before jumping over to me, it might be worth kind of mentioning and tie back to that workflow catalog.
Yeah.
That I mean, this Jupyter example that you just showed, I mean, it's just me. This Jupyter example that you just showed, it's really cool because it's in the workflow catalog and you can just go and click on it and run it. You don't have to, come up with any kind of a workflow. We call them fuzz files. The YAML file's already saved within Fuzzball. And that's something that with your new installation of Fuzzball, it comes already prepackaged and ready for you to go. So your users can already just open up the workflow catalog and clickety-click and be in a Jupyter notebook environment, coding things up.
Yeah, and we're adding entries to that catalog all the time. So the Jupyter server example that I was running here, completely unmodified. One of my colleague Wolfgang, who's kind of waiting in the wings here, developed that, and I didn't have to do anything to it at all. I loaded it up out of the catalog, clicked run, and it ran for me just as well as it did for him. The desktop one I had to do some development on because it hadn't been ported to services yet. In the past, we had provided that in the catalog, but you had to do the port forwarding work to actually access it. And when it ran, it would produce some log output that told you how to get that port forwarding working. But with just a small little addition to the YAML, now Fuzzball understands that that's a service that's running. And so you can connect to it with the web interface, and we'll get that back into the catalog so that all of our Fuzzball customers can access that and do exactly what I just did, have a virtual desktop running wherever their Fuzzball instance is running without having to do any work other than click run and click connect.
That's really, really powerful. I mean, you think about having disparate teams remotely. You can spin up VDI desktops for your entire team, whether they're the scientists that are in the lab or whether they're maybe traveling scientists that visiting universities or other research laboratories. They can access the same hardware no matter where they are and take advantage of that powerful compute system that's running underneath without having to send multi-$1,000 laptops out into the field.
Yeah, there is one thing I want to call out here, because it's easy for us to miss it again because we're using the system all the time, that the capability to develop something like that is as accessible to every member of your team also.
Right.
So there's no gating on, anyone could have put that Jupyter example together, because they just bring a container and they write the workflow and it runs, and then they can share it with anyone else on their team or anyone else in their organization. And because it's portable, it runs the same for any of them. Some systems like this, there's a kind of a hard line between publishing applications that are available for other people to run and the people that can run them. And you kind of can't get an application into the system without administrative support, without giving that work and expecting that work of someone else. And Fuzzball provides all of the power of that, all the capabilities of the system to everyone that's using it, but not everyone has to. You can pick something off the shelf and use it. But if you're the kind of person, if you're a power user or you're a grad student that's been tasked with it, you can do the work also and then make it available to others, which is really cool.
That is cool. So Dave, I think you had a few things you wanted to show off as well, right?
Yeah, absolutely. Yeah. And yeah, if you could share my screen and just to further emphasize that point that Fuzzball is really facilitating collaboration. So I'm going to give a shout out once again to my colleague Wolfgang, who Jonathon already mentioned before. Yeah, go ahead and share the screen, because the workflow that we're going to be looking at here, this is something that actually Wolfgang put together, and he actually started for me yesterday and I can just go in and look at this this workflow myself just by virtue of the fact that we're both part of the same engineering group. And so I can go in and I can have a look at this workflow. I can see the fuzz file that he used to create the workflow. I can open it up in the workflow editor. But I'm going to go through and I'm going to talk about this workflow in a little bit more detail, because now we're going to be getting into talking about sovereign AI, what we kind of like, started off talking about, and what we, kind of teased at the beginning. So I think, the workflow dashboard is good once you kind of know what your workflow is doing and you're like monitoring each of the pieces of it. But when you don't really know yet, I think that the workflow editor makes it a little bit easier to kind of see your workflows and see what they're doing. So I'll pop over here and we'll talk about it at a really high level, and I'll give you kind of a sense of what's happening here. All right. So backing up, when we first started talking about using Fuzzball for AI, one of the things that we started to do is to say, well, what would companies or organizations or labs or whatever want to do with AI within Fuzzball that they couldn't do just, without Fuzzball? And one of the things that we started to think about right off the bat is like, well, what do we want to do? What do we want to do with AI in our company? And, I think that that's a really good starting point. Just think about what we want to do and try to solve those problems. And then that's going to, dog fooding it like that is going to, make the use cases kind of pop out. And so one of the first things that came to mind, obviously, is let's build a model which has information about how Fuzzball works. And you can talk to the model about Fuzzball, and you can ask questions about like, what do I need to do in order to do X, Y, and Z with Fuzzball, right? And so how would we, and that's a great use case too, because we're developing Fuzzball. And, sometimes there's new features in Fuzzball. Sometimes these are things that we don't want necessarily to have out in the open yet, or they haven't been released yet. So we want to be able to host all this in a sovereign AI kind of way. We want this to be kind of like internal to our organization. But within our organization, we also want to be able to like share this out and have new employees come in and be able to ask questions about like Fuzzball and get up to speed really quickly and things like that. So that's exactly what we're doing here. So we've got this collection of services here in blue and jobs here in green. And I'll kind of walk you through and talk a little bit about what these services are doing and what the jobs are doing, what the dependencies are between them, and so on. So we're using this thing called local AI. And local AI is an open source way to host your own models. And so within here, we're hosting a couple of different things. We're hosting kind of like the open source version of ChatGPT-4. And we are also hosting a service that allows us to do text embeddings. And I'll get back to that and talk about that in a few minutes. And then we have a couple more services which depend on this one. So you can see with the dependencies set up that this one has to start first, and then these ones can start. We have one here called local recall. And what local recall does is it allows us to serve a vector database. So you've probably heard about people talking about RAGs, that is recall augmented generation. So essentially we can take text and we can vectorize it, we can put it in a database, and we can use that to improve our queries when we talk to a large language model. And so that's what this is going to allow us to do. And then we also have here this local AGI, and this is like for kind of creating agents and making your models agentic. And I'll talk a little bit more about that. I think a lot of people kind of already understand what agents are and what agentic means, but I'll talk about that a little bit when we start talking about this. And so here is where, up till now, if you've been following Fuzzball progress, you've seen us, show these workflow diagrams, and they've been these directed acyclic graphs. And you can kind of think of information or data or whatever flowing through the graph from the start to the end. Well, this still is a directed acyclic graph, but I think you have to change your mindset a little bit, because now what we have is a couple of jobs here at the end. This one is just sort of like a little checkpoint job to say, okay, do I have all my services up? Is everything healthy? And then if that is the case, then we can proceed on to this ingest corpus job. And what that's doing is it's going to our private GitHub repo where we host the Fuzzball, Fuzzball code as we're developing it. And it's grabbing the markdown files that make up all the documentation. And it's shoving that back up into this local recall service, which is up and running, and allowing it to create that vector database that it can use for the RAG sitting in front of the local AI here. So that's how all this is working. So you got to kind of change your mindset a little bit. It's a little different because we're not, information's not flowing. And just as an aside, what the actual data that we're putting into this model is actually hosted right here within Fuzzball as well. So it's this documentation. And I'll just give a little plug too while I'm here. You should know that this documentation is open. Maybe somebody can flash up on the screen or put into chat the place where you can go to get this. Actually, this is a development version of the documentation, so I won't put this link in, but maybe later on we can share the link out for the version which is not development. Jonathon just did so. All right, cool. So let's play with this a little bit. Let's go back to the actual running. So before I do that, did I forget to explain anything? Do you guys want to jump in and clarify anything or ask any questions?
Great. Maybe the only thing I'll talk about. So that local recall is the bit that I was talking about before. With it's maybe a little bit surprising how computationally intensive that is if people aren't familiar with how it works. And that's where you're using an AI model to kind of get the meaning of content that you're putting in it and index it by the meaning, by the semantic meaning, rather than just by keyword search. So that's its own AI workflow all by itself, which is kind of neat. It's been good.
Yeah. And just think about this too, how powerful this is from the perspective of any company that has a bunch of internal documentation that they want their employees to be able to go through and look at or talk to an AI model about. And the other great thing about this, since you're controlling all this yourself, as your documentation changes, you can trigger jobs to go ahead and update this nightly or weekly or however often your documentation is changing so that it's always up to date with the latest, whatever. So let's go back in and play with this. So now we've got, it's kind of a little confusing because we've got these jobs here at the end that have finished, but we still have services that are running. And we're in a situation now where the user, me, can interact with these services, but we're also having jobs that are interacting with these services, and the services are also interacting with each other. So I'll just kind of jump in and have a look and kind of show you what's going on. So I told you this local AI is a way to host your own models. They could be large language models or, image generation, all kinds of different things. But this one is a language model. So it's GPT-4. So let me jump into this model and say, okay, tell me about Fuzzball and its relation to HPC. And if I do that, it's going to have no idea what I'm talking about, right? It's going to say, well, Fuzzball string theory, which is cool because that's actually where the name comes from. But that's because this is just the model itself running without any RAG in front of it. So this is what you would get if you just went up to ChatGPT and you tried to ask him about Fuzzball, right? So let's go back over here and say, okay, we have this local recall service here, and that I can connect to as well. It's not really useful for me to do that because I've already, there's already been a job which has uploaded the data to this, and it's already created the vector database, but I could do something, manually, interactively if I wanted to.
Can you see it in here? Can you see that it's been put in? I haven't interacted with local recall directly yet.
Yeah, here it is.
Yeah, nice.
And yeah, I don't want to mess with it because I don't want to mess anything up. But here's where things really get fun. So this local AGI, so this once again is, this is a service to try to make your AI more agentic. And so what do I mean by that? I mean, what I have always heard, or what I heard several months ago, when people were talking about this a lot more, is that the idea is you have an AI agent, and that agent is like your coworker, right? You send the agent Slack messages and they do stuff on your behalf. And maybe they save it in Google Docs, or they create GitHub repo pulls, PRs to your GitHub repo, or they send you emails or something like that. Or maybe even meet them in Zoom like this and talk to them in Zoom. So this is a service to allow you to take these models and make them more agentic. And so we've kind of done, so Wolfgang has kind of done a little bit of that already. So we've got this Fuzzball agent here, and I can chat with this Fuzzball agent, and I can ask it questions like, tell me about Fuzzball and its relation to HPC. And if I do that, it's going to take a few minutes as it grinds away on that, but it's actually going to go and search the vector database, and it's going to use that to augment this query that I've given it and give it something that's a little bit more actionable that it can talk to ChatGPT about. And so it's taking a little while for this to work. This is the longest I've ever seen it take. So hopefully, the curse of a live demo.
Yeah, I was really happy with it. There we go. When we were showing it off earlier.
Wow, it gave me a lot. So yeah, so it says Fuzzball's high performance computing 2.0 enables you to create and run workflows in HPC. So it knows about workflows, various stages such as storage volumes, fetching containers, all that kind of stuff. So this thing actually knows about Fuzzball now because it's got this RAG sitting in front of it. So yeah, so I could ask it more things about Fuzzball, but in the interest of time, let me go back and show you some of the cool things you can do with this as well. So if I were to create an agent, so basically this allows me to really easily do things like connect an agent into something like Slack or something like a GitHub PR or something like that. And so let's say I connected it to Slack and GitHub. Then I could go over here and I could set up filters, and I could filter on specific like regexes, for instance. I could say, hey, within GitHub PRs, I only want the agent to be able to listen when I say at Fuzzball agent or something. I could create a regex to point to that. And so what I could end up with is an agent that I can talk to in Slack, and I can ask to go review PRs or go look at code or, do things like that, based on this Fuzzball workflow that's running here.
And to just hammer it home, like it's all running on our infrastructure, ours because it's our Fuzzball. If you're running Fuzzball, it's running on your infrastructure, and your data is never leaving your premises. It's never leaving your environment. Your data is in that database that's running, that's backed by storage that you control, and you own the entire stack.
Absolutely. And let me show you this as well. So another thing that we haven't really talked about, if I can find it in here, it might be easier to find it in a smaller one, but so there's a lot going on here behind the scenes. But if I go here, I can see like, so these are served out using, so the services themselves have some new sections within the fuzz file that allow you to configure like what port they should be listening on, what kind of traffic should come through. They have this scope here. And that's one of the cool things about these is you can set the scope either to just yourself and say, I want to be the only one who accesses this model because I don't want Jonathon to know about how I'm talking to my model about Dungeons and Dragons, for instance. And, I don't want them to know my DM prompts.
You don't want your players looking at it.
Yeah, exactly. Or you can have other people in your group. So we've got this engineering group here, or we can have like at this case, the entire organization. So anybody who's got access to this Fuzzball organization can access these services, and they can go in and start chatting with the Fuzzball agent about Fuzzball.
Yeah, there's also a public scope for services that you actually want to serve with Fuzzball as a production service outside of, maybe outside of your organization, but in any case outside of Fuzzball itself. So this is new stuff, but the goal is to support kind of that entire stack of internal services that you're using for your development and research right now, all the way to production services that you want to make available to maybe the rest of your company or beyond.
I didn't even know that we had that kind of scope. That's really cool.
Yeah.
Like you said, this is really new.
It's been GA for what, 2-3 weeks?
For various definitions of GA.
There you go. Fair enough. So I wanted to we're getting close to time here, so I wanted to kind of shift a little bit, if you don't mind. We've got 3 different questions that I'd like to address from the audience.
Awesome.
So Sean asked, is it possible to restrict an application or iteration of an app within Fuzzball?
Restricted to what? Yeah, I guess
I presume that's the text we have. I would say that like the application, like you are in complete control of the application. So at any time when you start it, the workflow doesn't have an access to any data by default. It only has access to data in volumes that you mount to it, or objects that you ingest as part of the workflow. So you have complete control of what it's able to see, because it only sees what you explicitly give it access to.
Yeah, and if you're talking about restricting it to who can see it, once again, you can restrict the scope to yourself or to groups or to the organization. Also, you're able to ask for specific resources. So you can restrict the CPU usage, the memory usage, the type of GPU that it gets, the type of networking that you set up. Yeah, you have very fine-grained control over everything that you can do with it. And you can also give it timeouts. So even if the thing goes crazy and keeps running, you can say, don't run this past 2 hours, and Fuzzball will just like any other batch scheduling system, it'll just cut it short at however whatever you set the wall time at.
Yeah, and you can build all that up as either a text-based YAML document that says what all is in your workflow and how it relates to each other, how the services are configured, how the data gets ingested or mounted into it. Or all of that you can, clicky button do in the web interface, or both. You can put it in YAML, bring it into the web interface, modify it, and then save it out to YAML again later if you'd like.
So awesome. Thank you guys for that. Sam asks if any part of the AI demo that we were showing off today is using MCP as well.
So the various components of the local AI stack are using MCP to talk to each other. So the local recall service is an MCP server, and the local AI service that runs the chat model is an MCP server. And then the local AGI application is an MCP client that sends prompts to those various services. So in effect, it tells you type your chat query, and it amends that query with it gives it the prompt, but then also tells it what other MCP services it has access to. And so it generates additional MCP calls that the local AGI system puts to local recall or other MCPs, like the Slack stuff and the GitHub stuff that Dave was showing off there.
Yeah, I maybe should have said at the start too that this is the actual system that we're using here is local AI, and that's built to be a drop-in replacement for Anthropic's OpenAI. So, for OpenAI. So basically the API is supposed to be exactly the same.
Yeah.
Awesome. Great to know. Alex asks, what versions of Fuzzball is this enabled?
This is available in Fuzzball 3.1, and the sub releases of that and beyond, which is the current release.
Let's see, a couple more comments coming in. Let me double check and make sure. So Hilmar, I apologize if I butchered your name. How do workflows fit into classical concept of resource management on shared HPC resources? Is there stuff like a scheduler under the hood that would take care of managing multiple users competing for compute resources?
Yeah, so Fuzzball is meant to compete in that space for sure. So it has a scheduler. That scheduler is a little bit different than a traditional HPC scheduler because it also has a resource provisioner. So it natively understands the idea of, oh, I don't have resources available, but I have access to cloud resources over there. I will start an instance and then run jobs over there and then deprovision them when they're no longer necessary. But then it can also schedule resources on, or schedule jobs to run on local kind of on-prem resources. All of this works using a container runtime called Fuzzball Substrate, which I like to describe as kind of slurmd plus Aptainer, or PBS Mom plus Aptainer. It's a CIF based container runtime that runs as a service and accepts work from Fuzzball Orchestrate.
And we just made some announcements recently that Fuzzball can now also use your existing batch scheduling system as a backend to do its batch scheduling. So instead of actually it running the queue and doing all those things itself, if you already have Slurm or PBS running, you can hook Fuzzball into it and you can say, okay, just make requests on my behalf to let users run their workflows through Slurm or through PBS.
Yeah, and in that situation, we're kind of using PBS or Slurm like a sub resource manager or a provisioner in Fuzzball's way of looking at it. It sees PBS or Slurm as though it's another cloud that it can provision resources out of. And then once it has resources from that system, it then dispatches Fuzzball jobs into them as normal.
Awesome, gentlemen. Really appreciate this. This has been a fantastic look at service endpoints and a conversation around sovereign AI. Excellent job to you and your team for all the hard work that went into this. I know that it's been a long road, but I mean, just what we've seen over the past couple of weeks with endpoints is absolutely amazing. So thank you both for joining us. So real quick, Dave, any closing thoughts? Anything you want to send people off onto the road with?
Yeah, well, just as I was kind of saying about new technology, just giving you new power, new ideas, and the ability to do stuff that you never even really thought of. I mean, I think that when we started doing service endpoints, really, we were just trying to enable HPC engineers who wanted to run things like Jupyter notebooks.
Yeah, it was all about Jupyter.
Yeah, and now we're like, oh my gosh, now we can host our own AI models, and we can host them internally within a company or publicly or whatever, and like it just keeps on going. So yeah, like mull this over and think about it, and I think we'd be really excited to hear what kinds of things you want to do with this.
Yeah, absolutely.
Yeah, local AI was an really amazing addition to the list of use cases, but the one that caught me was VDI. That's a really awesome use case that a lot of people, especially if you need some kind of graphical device attached to your VDI, this is an amazing use case for that. So that was really cool to see.
Well, and that's like that's a super broad set of potential use cases for what seems like such a small feature, and that's part of what makes Fuzzball so special in this space. Lots of things that are targeting AI are just that, and maybe even just one piece of software in that stack, or one API or one platform for doing it. Fuzzball is a general purpose platform that can use its features to enable a virtual desktop or an AI model, and it's doing a good job of spanning all of these use cases.
So, Jonathan, last comments for you. Any closing thoughts you want to share with our audience?
I'll just add on to what Dave said. We'd love to hear what excites you about this and what you would want to use it for, but then we'd hope to get it in front of you. We'd love to make Fuzzball available to you, so let us know and reach out, and we'll get started.
Awesome. And as we close, if you are curious about Fuzzball, about how to make some of these things happen, some of our other products as well, definitely head over to our YouTube channel. We're going to be creating tons of content, from tech tip videos to interviews like this one, to additional webinars. And if you have an interesting use case for service endpoints, or you're tackling some sort of challenge with sovereign AI, please head over to our LinkedIn, our Twitter, X. I refuse to call it X. It's Twitter. It will always be Twitter. I will die on that hill. But head over to find CIQ anywhere on social media, and send us a message. Let us know what you think you might use service endpoints for. Or let us know what sovereign AI troubles you're tackling. So on behalf of my guests today, Dave and Jonathan, thank you all for joining us. Really appreciate you all tuning in. We know that everyone's really, really busy, especially here we are at the end of January already, and we're all deep inside of all of the work things that we have to do. So, giving up an hour of your time to hang out with the three of us, really, really appreciate it. And a special thank you to Wolfgang, who did a lot of the prep for the demo and the infrastructure that you saw today, and Gwen, who's been helping me produce today's webinar. Really appreciate both of you. And so with that said, thank you all for joining us, and we look forward to seeing you all in the next webinar in 2 weeks. Thanks, you,
Eric.
and we'll see you then.
Thanks.